Hello, this is Matt Gaskill for Philosophy 160. Today I'm going to be presenting two problems. The first one is problem 7.8, the subproblem 3. And then afterward, we're going to present problem 8.8.2, which is the continuation of the 7.8.3 problem. So in this problem, we've got registers that are being filled with rocks, boxes filled with rocks. And it's a single node register. It has one arrow coming in. They've conveniently marked that arrow with ID number 0. And one arrow that goes out, but then comes right back into that same node A, identified that arrow as arrow number 1. And each time we iterate through arrow 1, we add one more rock to the box. And it just runs on endlessly. So I've started out with writing down kind of my cheat sheet. Depending on the type of arrow coming in and going out, we have a different template that we use to write our transition statements. And so we've got three kinds of arrow types. Today, we're just, for this problem 7.8.3, we only have to worry about one type of transition, which is the I and J plus type. So that's convenient for us. Just for reference, each of the variables that we've used here have been identified. X is the time passing through. V is one or more nodes. We only have one node conveniently as well for this problem, so that works to our advantage. I is the entry arrow number. So in our case, either 0 or 1 are the possible arrows, and J is the exit arrow. And so in this particular problem, we've got two types, two transitions. We've got where we've initiated the program, we come in on 0A, and then we enter the node, and we exit through arrow 1. So we come in through arrow 0, pass through A, and then exit through arrow 1, adding a stone. And so we've got that entry through 0 for node A, entering node A via arrow 0, exiting node A via arrow 1, and adding 1 to the node, to node A. And so this is our node type, which is, so we're going to use that particular format. Now what we're going to do is, to create the abbreviated statement, we simply take this format and we make the necessary replacements. So X remains X. The X just gets copied straight down from the template into your abbreviated transition. The same with X plus. We just take those three blue characters there, take them from our template, paste them right down into our answer. They don't get changed. We then take I. I is our entry arrow. So in the first case, it's going to be entry arrow 0. And we just replace that I with the value that we have for I, which in this case will be 0. So we bring that 0 over here. We do the same thing for J. J is this second variable after the comma. And for this particular line, it's going to be arrow 1. And so we bring that arrow 1 ID number, the number 1, and we replace J from our template with 1. And so now here becomes the tricky part. So when you're in, once you get past kind of that easy stuff, now you've got to figure out what are you going to do with these sort of ellipsis and node stone variables. So in our case, for this problem, it's fairly simple. We just have one node, and it's A here, but we're going to call it variable Y. We usually will go kind of X, Y, Z, W, so keep adding on new variables. So we don't have any nodes before or after our node here. We just have node A. And so we can basically drop the left and right ellipsis, and we just replace that V, and we just call it Y, just because. And then because we called V Y over here, we'll call it Y for the right side. And so then we'll end up with the Y plus here. So that's how you move from the template. The first trick, the first problem you have to solve is determining which of the types you have. Once you know which type, now you have a template. So you just copy and paste that template into for your answer, and then make the necessary replacements, the I's, the J's, the V's. Now, to get from this abbreviated transition to the full transition, let's take a look at how we might do that. And so what we'll do is we'll just copy and paste our abbreviated transition, the answer we got there, and then we'll go ahead and start making some modifications. So the first thing you do is you remove all the commas. You go through that problem, you remove the commas there. It's a little bit easier because we've got this thing color coded. You can do it in whatever order you like, but I like to remove the commas. The next thing I'll do is I'll move my parentheses to get them in the proper format, which is simply just one set of parentheses, one at the big ahead of the first R, and then the one that we have at the end. Now, what we're trying to do here is we don't like to have the number ones. We don't like to have pluses, that sort of thing. But we do like zeros. Zeros are fine. And we do like to have successors. And so the successor to one, the successor to zero is one, because one is the next number after zero. And so wherever we kind of see these ones or plus one to a variable, we've got to change that to a successor. And so, for instance, we have this one here that we don't like to see ones, but we're okay with a zero. So if we just say, instead of one, successor of one, successor of zero, then that's equivalent. So successor of zero equals one. If it were, for some reason, a two, it would be the successor of the successor of zero. So it would be like SS0 as an example. And so here we're looking for, we want one more than Y. So we want the successor for Y. So instead of plus one, we'll put an S. And then the same thing here for this X plus one. We don't want a plus one. We want to see a successor to X. And so now we've got this RX, 0Y, RSX, S0, SY. So this portion here matches what we have here. Now, all we have to do is figure out which variables we're using. So in this case, we're using Y and we're using X. And those are the only two variables that we're using. And so we go ahead and we just kind of prefix some universals on the front here, one universal for each variable that we use in our answer. If we had a Z, then we would throw on a universal Z, for instance. And then that's it. So now this looks just like that. So that's how we transition. That's how we transform our abbreviated transition into a full transition statement in this particular format. Now, what we'll do is then for the next problem, we're going to show how we transform this transition sentence into the new style sentence. And so we'll look at that here. This is the same sentence we were just working on, so nothing has changed there. And so what we're going to show is how we move, as an example, from this transition sentence into a new style sentence. So we'll just copy and paste this transition sentence, and now we'll go ahead and we'll start working on it. The trick here is the new style does not like to have successors, these little successors appearing in it. And so what it wants us to do is wherever we see a successor, we give it a new variable name. And so, for instance, we've got this sy, and instead of s, and we have s0, it doesn't like that. It doesn't like sx. Any of these where we have successor type situations, we want to get rid of those. And so what we're going to do is we're just going to say, well, whatever, we've got x, and then if we were to do x plus 1, that's the successor to x, we're just going to call that u, just because x, y, z, u, v, w, they, for some reason, we think they go together. And so we're going to call this a u. And now what we've got to do, though, is we've got to kind of account for that change we've made. And so we're going to use this successor predicate, and we're going to say the successor of x is u. We're just going to we're going to say that, and that'll be all we're going to do right now for the moment. And now we've got the next one that we're working on is this successor of 0. It's we're going to call, because we have the successor of y, and I told you we like to go x, y, z, u, v, w. We're going to call sy the variable v, just because we can. And what we're going to do, again, is we have to account for that v. We have to define it. And so we're defining v as the successor to y. And so we say the successor of y is v. That's what it says. And then the last one we've got here is the successor of 0. And so successor of 0, we've got a u, we've got a v, so we're going to call it w, just because they all go in that order in the alphabet. And we've got to now define what w is. And so we're going to say that w, the successor of 0, is w. And so we kind of all know that that's 1, but we can't say 1. We can only work in successors of 0. And so we've got this set up now where successor of x is u, successor of y is v, successor of 0 is w. So we've got those all accounted for with our successors. And the only thing, we've got to do a couple of kind of administrative tasks here. We got to match the format. And so the format is a conditional. So we throw in our brackets, we throw in our material consequence arrow, and now we're kind of getting close to the standard format that the new style is looking for. All we have to do now is throw on universals, and we need to throw on a universal for each variable that we've either previously used or we just introduced. And so we've already got our X and our Y because we use those from the transition sentence. But now we've added U, V, and W. So we've got to go ahead and add U, V, and W universals to our list. And once we've done that, now we've completed the transition from, between each of the predicates here, we need to add a conjugation. And so I've elected to mention that. And so I will make them red so that I don't forget to mention them later. And so for each of your successor predicates in between each one, we add a conjugation and statement and operator. So so now I believe we've got the same format as my answer sheet. It's always good. YV 0WXU. And so that is how you transform the transition sentence into the new style sentence. All right. Well, like always, if you've got any questions, hit me up on Pronto. All right, thanks.